Hi, my name is Lauren Oliver, and today I will be talking to you about the group compositional effects on aggressive interpack interactions between wolves. The reason that I chose this topic was because I work at an animal facility, specifically with dogs, and so I get to see their aggressive interactions and their interactions overall on an individual one-on-one setting compared to how they act when they're in small group or when they're in large group, and whether they're around smaller or larger dogs. And I see that their behaviors are largely dependent upon who they're around. And so I kind of wanted to see how that would play out in a pack-like setting where there are no inhibitors of these aggressive interactions, such as people like me whose entire job it is to stop these interactions. And so that's why I wanted to see how these aggressive interactions are carried out in nature in these pack-like settings with these wolves. Some things I'm going to be talking to you today about include pack composition, intra-pack interactions, kin selection, altruism, relative pack size or RPS for short, aggressive interactions. I'll be introducing some relevant research, and then I'll be ending off with a take-home message. Across many different groups, there can be several different disparities in the composition or the makeup of that group. And some of these disparities include the number of old or experienced wolves. And for the sake of this presentation, we will be using the words old and the words experienced interchangeably. The number of pups, or those who cannot participate in these aggressive interactions. The number of male versus female wolves, and the number of wolves in the pack at all. So is the pack larger or smaller than their opponent? Each of these disparities has its own respective effect on the probability that the overall pack will be successful during any aggressive interactions, and whether or not that impact will be a positive or a negative one. For example, because of sexual dimorphism that the species displays, where the males tend to be heavier and larger than the females, males are expected to not only be more aggression prone and display more aggression behaviors, but they also are expected to be a huge determiner of when, how, and if these aggressive interactions occur at all. Pack size overall has a major influence on these aggressive interactions, and not just whether or not there's a numerical advantage or disadvantage, but whether or not there's a numerical disadvantage or advantage in each demographic category. So does the opposing pack have more male wolves? Do they have more experienced wolves? And just to remind you again, we'll be using the words old and the words experienced interchangeably. And that just means that the wolf is experienced in a wolf battle where they have experience in these aggressive interactions. Really quickly, I want to point out the difference between intra-pack interactions and inter-pack interactions. Intra-pack interactions are any interactions that occur within the same pack. So these interactions are occurring between individuals within the same group. Interpack interactions are interactions that are occurring between different packs, between different groups. So intra-pack, we're looking at individual 1 and individual 2 within the same group. Interpack, we're looking at pack 1 versus pack 2, different groups. Looking specifically at these intra-pack interactions, packs are usually composed of an unrelated pair and then multiple offspring for multiple years. So this means that not only is there usually some level of genetic relatedness, but that means that these wolves have the chance to grow up together, which significantly strengthens the bond that they share and increases the chance that they'll receive any form of aid within these aggressive interactions. But not only do they experience this intra-pack familiarity, but they also go through different forms of group activity, such as foraging and hunting, and they also experience different forms of communication and coordination. All of these things have a direct impact on overall group success. Events such as natal dispersal may drive wolves to join packs that they're not directly related to. This is the time where wolves are permanently leaving their birthplace to go join other packs. And so this will limit not only the intra-pack familiarity and the amount of genetic relatedness that they can get, but it also experience the group activity that they can participate in. And this really lowers the chance that they'll be able to receive any aid during these aggressive interactions, whether that's when they're attacking or when they're being attacked. So after hearing these, consider the likelihood of a pack member or parent coming to the aid of an attacked pup versus the likelihood of that occurring without that intra-pack familiarity, without that bond, without that genetic relatedness. Conflict between conspecific groups or groups of the same species requires cooperation, coordination, and communication. And without these, there's a serious detrimental impact on the overall success in conflict. Kin selection and altruism. One thing that has a major impact on both intra and interpack interactions is the level of relatedness or the amount of shared genes. Altruism is when an animal exhibits or executes behaviors where there's an exchange in fitness, benefits, and costs. So we see this happen in aggressive interactions through helping and receiving help, whether that be when they're getting attacked or attacking. Under this umbrella, we will be specifically looking at the reciprocal altruism theory and kin selection. Looking at kin selection is the evolutionary strategy that individuals may decrease their own personal chance of survival to increase the fitness of their relatives, those that they are related to and share some genetic relation. Under this, self-sacrifice is expected to occur between individuals who carry a portion of the same genes. This means that these wolves are expected to help their relatives during ambush or attack at the personal risk, at the personal cost of predation or attack. On the other hand, under the reciprocal altruism theory, an individual would accept the cost, the personal cost of an altruistic act, increasing their own personal risk, even without the relatedness, even without the genetic basis, due to the chance that the individual might be able to reciprocate that in the future. So kin selection, we're looking at an increase in personal risk for the exchange of an increase in their kin's fitness with that genetic relation, whereas under the reciprocal altruism theory, we're looking at increasing the personal risk at the chance of future personal gain, and there has no need for genetic relatedness under this. So let's use an example. Let's use an example from the recorded interactions where 5 members of Pack B attacked a pup from Pack A. And as a result, a supporter from Pack A came to the aid of the pup and distracted, called attention to themselves, and led away the pup's attackers. To use technical terms, we'll call the pup that was attacked the recipient and the adult wolf the supporter. In this situation, if the parent is the supporter, the one that has the genetic relatedness, they're the one leading away the attackers, we would be seeing kin selection at play, since the parent is attempting to raise the fitness of their offspring, of their relative. However, an unrelated member of the pack can also benefit through the reciprocal altruist theory, where they may need assistance themselves later on in their own wolf life history, whether that's in that group activity that we mentioned earlier, when they're hunting and gathering, when they're foraging. So we're really quickly about to look at an experiment done by Kira Cassidy and Richardson McIntyre at the University of Nebraska, where they used GPS collars at Yellowstone to observe, catalog, and record 6 distinct interactions between the Yellowstone gray wolves. And this is their data. We are going to specifically be looking at the successful interference column and the supporter recipient relatedness column. Looking at the supporter recipient relatedness, we see that there is 100% a genetic relatedness in all 6 of these interactions, whether that relatedness is between parent offspring, whether it's between siblings, whether it's between a mated pair, or whether it's between aunt and niece, there is some genetic level of relation. Looking over at the successful interference column, it really shows the self-sacrifice that occurs in these aggressive interactions, as out of 6 of these interactions, only 3 of the interferences was successful. So a 50% success rate. Let's take a closer look at this supporter recipient relatedness. As we've already said, 100% of these interactions occurred between wolves that were genetically related somehow. But what's particularly interesting is that 50% or half of these interactions occurred between parent and offspring. So we're seeing that fitness-wise, it's as close as you can get, but we're seeing that there's self-sacrifice happening specifically between genetically related wolves, and it's helping them in these aggressive interactions, even though it may not always help. Because referring back to the example I used in the kin selection and altruism slides, pup 1's attack is on this chart under interaction number 1, and unfortunately that pup did not make it. Even though their parents had come to the rescue, the pup was found deceased a week later. So I'm about to introduce another study done by Cassidy and her team held again at Yellowstone with these gray wolves. And they were able to use GPS collar and observation to locate, monitor, and catalog some attacks. Doing so, they assigned 4 levels of certainty, ranging from definite to unknown. And when analyzing these results, they disregarded the unknown certainty column. The criteria for this was, it was definite if the attackers were seen killing or attacking the wolf, and if it was in the immediate vicinity, so that's within a kilometer, or if GPS location put a wolf at the site of the kill. It was probable or possible if the attack happened within a 15-kilometer vicinity, probable if there's some evidence of interaction, possible if there are no other packs in the area. They calculated the pack size based on sightings within a month and used the RPS model for selection, which I will talk more about in later slides, but it measured the total pack size as ratios. They also measured for 8 variables overall, 4 age variables, pup, yearling, prime aged, and old, 2 sex variables, male, female, the residency status, so whether or not the wolf was on their territory or they were intruding wolf or not, and the RPS. So let's look more at this relative pack size, or RPS for short. The RPS model for selection measures the total pack size and demographics as ratios comparatively. Keyword, comparatively. So that means that each pack is assigned equal size zeros to its opponents. To better explain this, imagine pitting a pack of 5 members against a pack of 7 members. Because we're using this equal size zeros and we're looking at them comparatively, the pack of 5 members would get an RPS score of -2 because they have 2 less wolves than the opposing pack, and the pack with 7 members would get a score of +2 because they have 2 plus wolves. So throughout the rest of this presentation, just remember that we are looking at the relative pack size. They're being compared against their opponent and not just overall numerical pack size. And these RPSs and ratios are highly correlated with an R score being higher than 0.9. So let's look at the results. Overall, there were 292 interactions recorded, and out of these, 121 interactions occurred between packs, or 41.4%. 166 interactions taking it the majority at 56.9% occurred between pack and individual, and only 5 interactions at 1.7% occurred between individual wolves. Now let's shift over and look at the aggressive interactions. Sorry. Excuse me, sorry, having some technical difficulties here. Okay, back to the matrix programming. 100% of the aggressive behaviors included some form of chasing behavior. However, only 71 interactions, or 24.3%, escalated to some form of physical attack, and only 12 interactions, or 4.1%, escalated to fatality. So what do these results mean? A backward stepwise selection was used in a multivariate analysis to generate the odds ratio, or OR, given the addition of more wolves. And in particular, we're going to be looking at the addition of more old adults, so experienced wolves, and the addition of more adult males. The chart on the right displays just that with the addition of up to 5 wolves. So for example, the addition of 1 wolf alone, regardless of sex, regardless of whether the wolf is male or female, increases the probability of winning by 140%. The addition of 1 experienced wolf, regardless of sex, whether male or female, increases the probability of winning by 150%. And the addition of 1 adult male increases the probability of winning by 65%. Which really goes to show that not only does numerical advantage significantly impact the odds ratio, but also numerical advantage as far as each demographic category. Are there more experienced wolves? Are there more male wolves? This graph here does a better example of visually showing the impact that each disparity can have. The red lines represent the loss or numerical disadvantage of adult males on top. Adult males on bottom, old adults on top. And the blue lines represent the addition or the numerical advantage of adults and old adults, adult males and old adults. So let's look at chart A on top, old adults. If a pack has an RPS, a relative pack score of -4, but the addition, the +3 numerical advantage of having 3+ experienced wolves, their probability of winning is increased by 50%. Let's look at if they had +1 old wolf comparatively, their probability of winning would only be increased by 10%. So that goes to show that but just the addition of 2 wolves, their probability of winning has been increased by 30%. By 40%, a significant increase, which really goes to show that numerical advantage can have a major impact on these aggressive interactions. The most significantly influential demographic was the presence of additional male or additional experienced wolves. And again, just to remind you, experienced wolves does include both male experienced wolves and female experienced wolves. And male experienced wolves double the odds of them winning or being successful in these aggressive interactions. But overall, the most significantly influential demographic was the presence of additional or experienced male wolves. Older wolves are more likely to succeed due to their collective experience that they bring, and they can use this experience to better assess their opponent, better assess their fighting ability, and whether or not it is worth engaging or disengaging. Alongside this, male wolves, these aggression-prone individuals, impact these interactions. So even if pack sizes are the same, they have an RPS score of 0. If one pack has more male wolves than other, then they have the advantage, as these are, due to sexual dimorphism, larger, heavier, and more aggression-prone individuals. Overall, the winning packs not only had the numerical advantage as far as having more wolves overall, but they also tended to have more wolves in each demographic category. So looking at the average pack has 2.36 males, whereas the average winning pack had 2.65 males. The average pack had 2.75 prime aged wolves, whereas the average winning pack had 3.04 prime aged wolves. So again, this really just goes to reiterate that it's not about having just the numerical advantage, but it's also about having the numerical advantage in the demographic categories where it counts. The male wolves, the aggression-prone individuals, the experienced wolves who have the experience in these conflicts. So let's look at the influence of RPS, relative pack size, that we've been talking about this entire presentation. The influence of RPS is the main factor that suggests that packs larger than their opponents with a numerical advantage are more likely to win. So an increase in the number of pups or those that aren't able to participate in these interactions quite yet decreases the probability of being successful. Inversely, the increase in males or the aggression-prone individuals increases the probability of winning. Territoriality has an effect. So whether or not the wolf is on their home territory, they have that territorial familiarity, or whether the wolf is intruding and lacks that territorial familiarity has an impact on the probability of winning. And finally, whether or not there are more or less prime-age wolves not only impacts the probability of winning, but also impacts the probability of these aggressive interactions occurring at all. So take-home message. Wolves are social individuals that run in pack settings, and in these pack settings, aggressive interactions are bound to occur. These interactions largely depend on the composition of each wolf pack and their opponent, whether or not the pack has a numerical advantage or disadvantage, and whether or not that advantage or disadvantage is in each demographic. Whether the pack has more male wolves, more experienced wolves, or more experienced male wolves has a significant impact on these aggressive interactions, and overall goes to show how group composition plays a role in these aggressive interactions. Is there the advantage or disadvantage? Are there more aggression-prone individuals? Is there more collective experience? These aspects of group compositionality all play a role on the odds of winning and on the probability of success in any interaction, but specifically in any aggressive interpack interaction. Thank you for your time.